So today, I want to give you a different talk for me. I'm usually a very technical person, and I try to put as much technical stuff as I can in my slides. And I decided to give it a different spin, so I'll talk to you about some technical topics. I'll talk to you about a life of a project. First, a little bit of introduction. I consider myself those things when I'm at my job, but I think the most important thing is that I'm passionate about what I do. I wouldn't do anything that I do the way I do it if I wasn't passionate and I didn't love it. And that makes me go to conferences, listen to podcasts, and do so many more things just to learn stuff that I'll probably never use just because I find it interesting. I'm one of those weird people that just one afternoon would take the Go runtime sources and read them. Because, I mean, it's good code. I might end up learning something. I'm probably not going to use it, but I mean, it makes me a better developer, probably. And I wanted to tell you that this talk wouldn't have been available without them, and I don't mean the plushies, but other Gophers that contributed to it, because it's not just my experience that I collected, but experience from at least 12 different people that I asked about, and the main question was, if you could go back in time, and I asked mostly to people that have been using Go for mostly 4 to 7 years, if you could go back in time and give yourself a tip, one suggestion, one piece of advice, what would you suggest to you? And the answer was sometimes surprising. So, this talk is for everyone. I don't care if you've been writing Go for 10 years or 5 minutes. Well, 5 minutes would be an interesting talk, a different one, for sure. But this is probably going to be useful somehow. And what I want you to do is just take some bits and pieces and make them yours. I don't plan, there is a lot of stuff in the slides that follow. I have links, and those are public online. So just make it yours. Learn what you can, and for the rest, just enjoy the ride. The way I see problem is an interesting bit of things. Problems are lovely, because when I see a problem, I see room for improvement. And that's how I like to approach software. For example, I think this API is slow, to take an example from previous talk, but I don't want to rewrite my entire service from Ruby to Go. What can I do? I just put something in front, something small, something that solves my problem, and that is an interesting challenge. And I want people like you to tackle this kind of problem in this way, which is, can I make this better? And this is a couple of definitions that I like to spread around, which is, software is a machine-readable, human-writable solution. And the accent is on human-writable in this case, but also human-readable, if you can keep it that way. A programmer is a human that knows the problem. I always say that programmer should always have a clear problem in mind they're trying to solve. And a programmer should always be its first user. You should be your user or know your users very well. It's very hard to solve something if you don't know what you're solving. And once you know your problem well, you start having ideas. And this is a beautiful, creative moment. And this is why I always consider myself to be more closer to a creative job than just plain engineering. Well, engineering can get creative and can be sometimes be considered art. And by art, I mean you take your problem, take some inputs, take some outputs, and you're like, okay, how do I get from here to there? And you write your Python script, your Bash script, your Perl, maybe not Perl, but you write your solution, and you get there, and you're happy because you found what is the link in between, what those two mysterious things which are input and outputs. And it's very important that at the point you ask around. And you ask people, you just go to someone that doesn't even know the problem, and you ask them, okay, I think I have this problem, and I think I can solve it this way, what do you think? I found most of my bugs in my code at this point, and I haven't even started writing code. Because at this point, some people, some of your colleagues will just go like, why don't you use the library? Or why are you looking at the problem this way? Isn't it simpler if you look at the other way? And that is an enlightening moment. And this is where you get. At this point in time, you just know where you started, you don't know where you're going, and that's why I like to use Go for this. Because Go allows you to solve what I call the leaf problem. It gets out of the way. You have one problem to solve, you write a main function with all the code in it. It just takes what you need, takes what you have, outputs what you need, and then you're there. You're not designing, you're not writing an UML graph, you're not drafting some weird class abstractions. This is a beautiful moment because you can just paint. You take Go and you use it like a canvas. You can import any libraries you want, have as many dependencies as you want. You can allocate everything on the heap, doesn't really matter. And you can use arbitrary amounts of CPU, and you can use bubble sort if you like. Doesn't really matter. You just, or bogo sort if you are very courageous. This allows you to check that you got the problem right in the beginning, and you have a first implementation in Go. And most of my projects at this point stop. To be honest, I just realized, OK, this is good enough. I can just stop here, or maybe this doesn't even make sense. But if it survives, as Bill says, don't get hung up in all the idioms. I've seen too many people trying to throw a package CMD module infrastructure with these 3 different packages to separate model view controller. Don't do that. Go is simple. It gets out of the way. Don't put yourself roadblockers in front of you. Just go. Pun intended. At this point, your solution might look like that. And I'm not even kidding in the missing error checks. I have programs that do this for my experiments, and I'm fine with that. I usually don't push this to prod, but I mean, I know that some people have courage. And at this point, you want to make it grow. And so you start adding things. But before you do, you have to resist a little bit, and you have to throw away everything that you can and refactor everything else. Force yourself to refactor. Just changing maybe a little bit, change the signature. Now you know your problem a little bit better, so you probably know how you want to address this. Keep your solution working. Try not to break it during the refactor. And also, you will start noticing some patterns. And at this point, patterns will start talking to you and emerge. You will have 2 things that behave very similarly, and you will be tempted to put an interface around them so that both implement that interface. Don't do it. Not just yet. Just keep it in mind. You have seen 2 instances of the same bit, but you still keep the working implementation, you still keep structs, and you still keep it simple. And now it's time to turn your inputs and outputs into tests. They don't have to be refined tests, but this will help you as you go to keep it closer to the original problem. This is not just a matter of tests for correctness. It's also a matter of tests just for the sake of not having to run a main every time. Just about that. Now, at this point, I've seen many people even advocate for some patterns. If there are many things in this talk that you might not agree with, this is one thing that I always try to push, which is you can export interfaces that you consume. You preferably should not export interfaces that you produce. There are some few examples like the net package in the standard library that export an interface that is returned. There was a good reason for that, and unless you have a very good reason for that, don't do it. And for sure, never use an interface just because you want 2 implementations, one is for the tests. Try to stay closer to your data structure, because otherwise your unit tests are not going to test your unit. They're going to test some test code and a little bit of the rest of the code. And I've seen too many pieces of code testing units, passing the tests, being pushed to prod, and having an issue. I've seen people checking for some headers that only appear in the responses, in the requests, and the tests were passing because they were constructing the header just during the tests. They should have used the proper request. So try to stay closer to your stuff and follow the postel law. Be as open as you can with what you accept. So use small interfaces in what you accept. And be very strict on what you return. Be very precise on what you return. For example, if your library is ever going to return an error and a value, always document that. If you're going to return something, it should be a struct, not an interface. And one thing that I like to do, since I work a lot on web services and libraries for web, is when I need to change the headers on a response writer, I don't take an HTTP response writer. It's 3 methods. I don't need 3, I just need 1. So I export the header interface that only has the header method. That is going to make it simpler for everyone to use my library, and they can just stub a response writer if they want to buffer the requests so that they can reproduce them later. And they just need to provide me 1 method because it's only 1 method that I'm going to use. So try to keep it closer to what you really need. At this point, we are at Go 113. And so you might want to consider, OK, what about errors? I mean, I'm going to encounter errors, and Go makes me face them up front. So I want to maybe expose some of those. And at the point, please tell yourself, do I really need to? Because Go 113 allows you to do this when you do an error F, which wraps the error in a way so that it formats as it would be with the %v, but it's still unwrappable. So the thing that you return, the caller can inspect it and see what was the source of the error. By doing this, you make a little bit of your code, your internal unexported code, observable. So if in the future, instead of using 1 package to do your thing underneath, you switch to another implementation, your public API is going to change, and no one is going to notice. So only do that for sentinel errors. So when the caller is expected to check if there was an end of file, you can wrap an IO-EOF inside an error, so they can do error.is IO.EOF, and they can check if the file ended. But don't promise something you can't maintain. And that is a promise right there. At this point, you might want to switch. If you're writing a library, try to write a small main for it, just to be a user, just to realize how clunky of an API you wrote. And I am very well renowned to writing clunky APIs. And if instead you just were in the main package, you might want to consider the usability of that for someone that just wants to import your stuff and use it for other things. And don't be afraid to refactor. Go is very good at refactoring, I think. And it's very simple to refactor. And about that, at this point, there are 2 things I would like to introduce, which is the technical debt multiplier and the technical debt multiplier again. Go is simple to refactor, tends to have a very little impact on the technical debt, unless you do these 2 first underlying things, which is having a global state or exporting asynchronous API. Don't accept channels. That is very hard for your user if they don't want to call you asynchronously, but they just want to wait until you're done. If you export a synchronous API, the caller will be able to run you in a Go routine, take your return value, and just push it to a channel. It's 3 lines. Anyone can write those lines if they just, go through the tour of Go. They know how to do that. We Gophers know how to do that. Doing the reverse, so turning an asynchronous API into a synchronous one, that is difficult also because sometimes you don't know how to tell it to stop when you don't need the results anymore. So you can start considering accepting context and check for cancellation, but try to stay synchronous. And at the same time, remove global states. Then there are a couple more things that you can do, like think about security. I always say these because it's my job, kind of. Don't do one more thing that is colored functions. If the only way to call a function is to change the signature of the caller of that function somehow, you're doing something wrong. You're writing JavaScript, for example. Think about async functions, that you need the channel to be passed everywhere. That kind of makes the code a little bit harder to refactor later. There are some high-level primitives that you can use if you still want to do parallelism. So let's say that you have a job that is very easy to parallelize and you want to finish fast. You can do these kind of things. You don't have to use a wait group for that. If something could error arrive, you can use an error group and just spawn your work in parallel and collect your work when it's done. Error group is very nice because it allows you to say with context, and that you can check for cancellation. The first Go routine that is going to return an error is going to cause the context to be cancelled. So when someone calls your API, they can wait for it to return, look synchronous, look not concurrent and not parallel, but you're actually using all the hardware that you have available. And I find that beautiful, to be honest. The link that you see in my slide is clickable and leads you to the GoDoc. Every time you spawn Go routines, be sure that you know how they end. Just don't let them run. About global state, I've seen different solutions. So in this case, those 4 things that you see on the left, which are time.now, reading a command line flag, calling the logger, or opening a file, those access global state. Usually when people refer to global state, they only refer to global variable. It's not just that. Anything that you do that is observable by other functions, like opening a file, changes the global state. These not just make your tests harder to write, but could make your test compromise the state for other tests, and could make your program behave in unexpected ways. And I've seen some things not work in prod, but work in other environments. And it was almost always because of those kind of calls. Now, Go doesn't provide you with a framework to get around that, but you can just use normal functions and normal types. So those 2 solutions are the ones that I've seen the most. The first one, just pass around the state, and you have helpers to unwrap it with the thing that you need. Those things are cool because they prevent you from importing the actual package. So if you do time there, in that file, you can't import time anymore. But that kind of gets hard to get around, so I tend to prefer the second one, in which you just pass a state that has what you need. And in your signature, you could also change the state, if this is an interface, to say, I just need time. So you can use a subset of the states. So when someone tries to access global state, code doesn't compile anymore, and they have to change the signature, so you realize there is something more that you have to care about when you call this function. This is normally referred as to dependency injection, because you don't know who is going to implement those functions. Normally, it's the actual standard library, or the testing files that you have, of someone that provided you, one of your users of your package, they provided you those implementation. Sometimes you don't need the actual time, because that's a syscall, that's expensive. You just need an incremental clock. So that can be implemented as just a counter every time you call increments by 1. This makes your code way more flexible, as long as you are coherent. Don't use both, please. Now we get to a pretty difficult topic. At one point, your code is going to be too big to keep in a single package, and you're going to realize that you have a lot of types in your thing that don't have nothing to do with each other. And so you need to factor them out. This takes a while to get right. Sometimes even the most experienced people will just get it wrong, and you need to go through another refactor again. And it's kind of an art, and I don't think I completely fully grasp it. But as a user of packages, I can tell you names are important. Packages provide insulation between responsibilities, but they're expensive to deal with, because you have to import stuff, you have to separate things, you have to decide what you export. Up until now, you could have had everything unexported, just private to you. So sometimes you need to break them out. It's expensive to consider the cost, but most importantly, don't package stuff just for the sake of it. These kind of things tell me nothing. If I'm looking at your code and I see there is a helper package, helper to whom, from what, and why are my first questions. And you don't want your users to see that kind of patterns. Why would anyone collect stuff together that has nothing to do with the rest? Packages should mean some kind of commonalities. And try to keep your packages dry. I know there is a lot of standard library in this slide that I'm blaming, but context.context, seriously? Try not to do that in your packages. I mean, or ring.ring. Wow, this is ringing a lot. What is it, a phone? It's, I mean, come on. This should clearly be containers.ring. And there are many things that you can find around that just, the main data type that is inside a package is the name of the package, uppercase. This is not helping your readers, and it's not helping, for sure not helping you write your code. So why? So those are just proposals that I have and some differences that I've noticed. I'm still trying to wrap my head around the how would I call context, but I'll leave that as a task for you. I still don't have an answer. Scopes seemed fine, but yeah. At this point, you accept context, you have a good API, you have your library, and you want to ship. But don't ship a 1 point something. 0.1 is fine. You're still working on your stuff, you're still adding your documentation. Maybe when you write your documentation, you're going to realize, hey, there is no way to abort this task. Maybe I'm going to change it a bit. So try to keep a style, a coherent style. Try to state what you're trying to solve very precisely, and what you're not trying to solve, that's also important. And pick a license, tag a commit with 0.1 something, and just be good with that for a while. Just tell people how they should contribute to it. You can pick the Go contribution guide. Maybe it's a little bit too heavyweight for some things, but I mean, you get to this state. And at one point, someone is going to read your code. And, you know, there is a nice wiki page on GitHub that is the Go readability review comments. Those are comments that were mostly put together in Google. And in Google, we have a very precise code review mechanism in which every code must be reviewed. And so some comments started to emerging way more than others. So they were put together, and this list then got contributions from the community. This is a very good wiki page to start with. Read it, then go back to your code, cry a bit, and then try to start fixing some things. Always prefer readability over writability. Don't be smart. Don't be fast if that makes your code less easy to read. And most of all, try to strive for glanceability. I'll describe the concept in a bit. This is code, GoCode, actual GoCode, from which I removed everything that is not a statement or a keyword. So this is the code. I decided to keep because there is a common enough pattern for my eyes to recognize easily, and also have syntax highlighting for it. So I saw the code on the left during a review, and I started giving some suggestions until it got to the state on the right. Yes, it's hard when it's behind me. And this was what my eyes had to do initially to read the code, and this is what my eyes had to do after the refactor. If you just remove the code completely, you see how many jumps I needed to do in the beginning, and how many less jumps I had to do at the end. This is what I mean by glanceability. I could just read the code by just moving my eyes on the left column, and I could understand what was going on. And you should keep your main code left aligned, and every weird or different situation right aligned. This is what Matt Ryer calls the line of sight rule. If you read Go until we get a try statement, you can align to the left all the happy path, and that is almost always going to be true. And the error handling is going to be on the right. So most of the time, you won't even do that extra jump to the right to understand your code, or someone else's. Now, people are not just going to read your code, but are going to rely on it. And this is what gives me anxiety, because I don't trust my code usually, and for myself, let alone for someone else. And this is why I get very paranoid. So I start throwing CIs and tests and fuzzing. And my CI is also going to test for coverage. So basically, if someone submits more code to my library, which is usually me, and the coverage, overall coverage goes down, my pre-submit is not going to pass. So I need my coverage to stay at the level it is right now. If I submit more code, should have its tests. And same for style. If I decided on a style, that should be preserved. It's very easy to write analyzer for Go, and you should attend Michael's talk tomorrow because he's going to talk about it. There are some checks, extra checks that you can add to static analyzer. It's pretty easy to do. And then what I do is I add fuzzing. Fuzzing is still not very well supported in Go, but there are some things that you can fuzz and you should fuzz. Please consider fuzzing your code if it has a lot of possibilities, like a parser or a very complicated stateful cache. Fuzz is fun, and it's very rewarding. You can run a fuzzer for a few seconds and find a lot of bugs in your code. It's good. Now it's time to publish a security policy. Please do. Please let me know how do I report vulnerabilities to you, and stop panicking. Grab for panic in your code, remove it, turn it into errors, some sort of them. A little bit about testing. Who knows what table tests are in Go? Okay, basically everyone. For those who don't know, it's basically just you create a struct with what you want and what you're going to pass to your function, and you create an array, or a slice of that struct. And then you just call t.run on your tests, and every run, you pass a different input, and you get a different output. Always test with race, and always try to keep going. So use error wherever it makes sense. Don't do fatal, because otherwise, if I change your code, a test fails, maybe it takes 15 minutes to spin up the Docker container that I need to use because it targets a specific platform. Then I run the test, I see the test, okay, I fix the bug that I introduced. Then I rerun the test and another test fails. And I'm like, couldn't have you told me before? And that person I'm blaming is usually me, so this gets pretty annoying. Use libraries. So dependencies are not necessarily bad, specifically if you just depend on something during tests. I find the CMPA and CMPOps packages very good for this, because I found myself many times trying to compare maps, and you can't compare maps in Go, and you can't even compare byte slices. With this, it becomes one line. It's maintained by Google, and it's pretty good quality. It's also pretty fast, and it allows you to have diffs. So if you're comparing big structs, it will just tell you the single field in that struct that differs, which makes tests much easier to read. And don't forget that tests can also be documentation. So if you write a test this way, that is going to appear in your GoDoc, and it's going to be testable code that people can use. And when you run your test, that is actually going to check if the output of the previous function matches what's commented below. So you can say output cat, and if someone calls do nayan and it doesn't return cat, your test is going to fail. But this is also showing up in your docs. So it's a pretty strong doc if your Docker compiles and runs. Who has used coverage here? The coverage tool? It's pretty good, especially since they introduced the HTML version that allows you to just see in a different color lines that are not covered. This only currently supports green and red. Sorry about that, but CSS is not that hard. I've been told I don't touch that stuff. We got to the time of contribution. People that rely on your code are going to find something that is missing and are going to find some problems. Don't do all the work yourself. Don't overwork yourself. Don't try to address everything. Don't try to be in control. I always found Go community to be amazing for so many things. Try to allocate time for code reviews. If some people are good for you and they think alike, like you or like the person you would like to have on your team, try to find a way to promote them to your team, or if they're in your company, try to ask them, are you interested in this project? Why don't you come over? Make it very precise what you want to achieve, and if they're in, just bring them in. Most importantly, document your decision, because at this point, some people are going to go through your code and ask, why did he do that way? And if you're like, she could have chosen a different pattern at this point, why? you want to give them an answer. So if you choose something under specific condition, put the conditions there in a comment. And if those conditions are not going to be true anymore, because maybe the library you rely on changed, people can just fix your code. And you don't even need a discussion, because someone can just say, that thing that you said is not true anymore, so let's get rid of this hack. Not that I do hacks. No one does that. There is a precise reason why this is slide 36. I've seen too many people optimize before time, to the point where they optimize in the first early draft in Perl that they wrote. Don't do that. Good code is code that is easy to read and compiles decently. Don't make it try to do anything very fast. Your APIs shouldn't be affected by the speed that you want to go at. I've seen, like, for example, a JSON library that allows you to parse a JSON very fast, but then it doesn't deserialize it into a struct or a map. It just gives you accessor, so you have to do get of a byte slice for the key, and it's going to return stuff that somehow matches that byte slice as a key, and it's going to return a slice of byte slices for the values. I mean, yes, it's 15% faster than the standard JSON parser, but come on, who wants to deal with that code? Because you're going to maintain it, so please don't do that to yourself. One thing that you could do is to start profiling your code. At this point, you'll probably roll this somehow in production, or some people are going to heavily rely on it. So you can add these 5 lines behind the flag, so that people can read their traces, read their log, profile their code. This thing, please don't register it on the default server mutex. Don't use the default servmax in production, because otherwise you're going to expose debug information, including your command line, to the internet. And command lines usually contain keys. I've seen too many servers exposing keys to the internet just because they expose this. There is a very simple 4 lines way to expose this only internally, and the trick is that local host that you see there, because then Go is going to filter that for you. And then you can just do go tool pprof and connect to it. And you can actually do this in prod, because until you hit the endpoint, you're going to have 0 cost for this library to be imported. Usually what I do, and what we do, for example, in Google Cloud, is to collect those traces regularly. So once every hour, we run a trace or a pprof or a heap for 5 seconds or stuff like that. It's not going to impact your service, especially if it is replicated. You just run it on one replica at a time. So your users are not going to notice, but you have real production information on what is not going well. And then you can optimize, because visualization of that kind of data is good. You can have flame graphs, which are easy to read. You can have traces, which are impossible to read. And you can deal with those things and try to work with them to the point where it tells you how much time was spent on a line. So don't blindly optimize. Just take the top 10 functions in your code, because you can also filter with regexes, and say, just take my package, or in this case, I was filtering for github.com, and see what are the top 10 packages on which I spent time on. And in this case, I was spending too much time unpacking domain names in a DNS thing in a server that was just a proxy. That was surprising to me, because I didn't expect that. I expect literally anything else to be the blocker, not this. And then I found out after I removed that I spent most of my time in math.big. And I was like, I'm not even using big. What do I use this for? Basically, the server I was connecting to was a Cloudflare server that only used the cipher, that on my hardware wasn't really efficient, so I had to do math big in Go to calculate some curve in an elliptic curve thing, and that was taking up 89% of my CPU time. So I just disabled that ciphers, and that was it. So optimize the right way. And when you get there, consider that the compiler can give you a lot of information. Like if you see that you're using your garbage collector too much, you can easily see where you're hitting the heap and where you're hitting the stack. This is just what you need to do. And you can literally take that, and if you use editors like Vim or VS Code, you can just use that as a result for an analyzer, and that is going to show up at the line where your variable is escaping to the heap. So this is easy to use, and it's simpler than trying to guess. The coloring is done with sed. I have a bash script in the speaker notes. Please don't rely on it. It's sed. You can use benchmarks. One common mistake is to not reset the timer after the startup. Try to do that as much as you can because you want your benchmarks to be available. And when you optimize, always run the benchmarks again. Try to make sure that you actually optimized. Sometimes you can't run your benchmarks on the production hardware. You just run them on your laptop, and you're like, OK, so if I use this constant, my code is going to run faster, so let's just use this constant. And for example, for the karatsuba function to compute fast multiplication in math.big, that constant was computed on a friend of mine's laptop, and that is in the standard library. I mean, it worked well on his laptop, but it doesn't mean it always has to be the best constants. So for some things, you can run benchmarks in your main code, so not just in tests. You can just import the testing library, run your benchmark, take out the value, and put it in a variable, and you use that in prod. It's going to make your cold start a little bit slower, but you know that you're actually using data that makes sense. At this point, some people might ask you, why are you not also doing this? I would like this feature to be added. Don't be afraid to push back. You can't solve everything. You're not Chrome, and you don't want to use the resources that Chrome uses. Try to do just what you need. It's good to create a satellite package that maybe depends on yours or changes something. It's good. Just keep it the Unix style, the Go style. Do one thing, do it simple, do it good. Don't change your views just because someone tells you to. Stay on the original problem. At this point, you will have people with you, people that you promoted to your core code. Help them grow. Help them maintain that code. Create tutorials, and please have a code of conduct. When you discuss online, there are 3 kinds of people that you can encounter: trolls, gremlins, and people that want to hate on you as much as they can. And sometimes a 4th type that are the people that you actually want to work with. Have a way to kick them out the conversation if they're just toxic. Your time is precious. Value it. Give away responsibilities. At this point, it's also fine to become a mentor for this package. You don't have to start a project and be the maintainer for it forever. That is not, every one of us has some projects that they maintain. You don't want to be maintaining them for your entire life and make them be a weight for you. You want to make good use of your time, so trust people. I came to go for the concurrency. I came to go for the language, and what I always say is that I stayed for the community. We have an awesome community. We have one of the most inclusive, open-minded, energetic communities that we have. So pick someone from that community and let them help you, and be open to confrontations. Some people are going to tell you your original problem that you're trying to solve is actually different. And now you spent 2 years on this project, and you're probably going to think, do you really think I'm that stupid? That I spent 2 years on this and I don't know it? Sometimes, yes. And it's fine. You were wrong. They helped you make your code better. Be good with that. And sometimes you just have to explain people that they might be missing some pieces. It's fine to be wrong. People are wrong on the internet all the time. And now that you rely on projects and people rely on you, consider contributing to them, but most importantly, when you find another problem, consider switching to that. Now your projects can run on its own, and yet you might just be better doing something you're better at, because now you've changed. We grow, we change. Don't let things hold you back. And that was my talk. Any questions? Okay, then I think, okay. Then I think our first day of talks, oh, ooh, is that a question? Okay. I think I'm supposed to give you this, or?
On small details of your talk, you mentioned to never use interfaces for testing. I was just wondering if you have some advice on testing time-based stuff. So maybe you have a rate limiter and you want to test.
What I meant is that when you implement something in your package, you shouldn't use an interface instead of your actual struct in your code. But if something accesses the global state, like in my examples too many slides back. But if something needs to access global state and you want to control the global state, that is, I think, one of the best cases for an exception for that rule. Every rule that I use in my talk has exceptions. You can't make those rules out, otherwise it would stop being an art.
Thank you very much.
Okay. Then I think we're done. Enjoy the rest of the evening.